Uh, well, what else? What else could be happening here? uh, could be a defective tube. That's possible too. I just put two tubes in. How do I know they were even good? How do I know any of the tubes in here are good? Only because of the assumption that, well, now that makes some sense. That the tubes I just put in, one of them has a defect. Because that would explain why somebody would do all this work and then sell this thing, but it has a problem. Well, the problem is the two tubes. One of the two tubes I just stuck into it. Okay, let's eliminate that possibility because it's not very likely. Not very likely. These two guys. So we'll start with this one. We'll test the 35Z5. That's definitely what's supposed to be in there, right? 35Z5 GT. Okay, tube testing time. Okay, here we go. 35Z5. 35Z5. There's two tests for this tube. The first one is called a ballast test. It's kind of unusual. So I believe I've set it up for that test, but let's just double check. JR 0537 0. Nothing else matters. With this test, we should find a short on all these short settings here. Should show a short. Let's find out. Give it a chance to warm up. Oh. Okay. Kind of. Whoops. A little bit of a boo-boo there. Shame on me. Two things. I left this set on 50 from the last tube I did. Should always crank this way back down at least to 6 when you're done. And I didn't. And I stuck this tube in here without checking this. 35 is where it should be. So I ran it with 50 for a bit. Maybe that just cleaned it up a bit inside. Okay, shorts on everything. So we're watching the short light. Short. There's no short on 2. No short on 2. Well, no short on 2 and 3. This is a lousy switch here. Nothing on 2. Did it say 2? 1, 2, 3, 4, and 5. No short appearing on 2. Is that the problem? Right there? Was my imagination, or was this tube getting brighter and duller as I was doing this? It's imagination. I should get another 35. Z5, stick it in here and compare. Since let's set up for the other test and check for shorts. This is a more normal test here. So JR 05070 05070 060 on English. Not that it really matters. And it's a rectifier. Has to be on English. Does matter where this is set. P3 to test a rectifier, and rectifiers. There's a. I thought there was a rectifier OK thing here. Yeah, that's kind of weird. So most of these guys, they have a spot like this one says diodes OK, and then they have another spot rectifiers OK. And I've done dozens and dozens of rectifiers in here. How come I've never noticed this before? Well, you know why? Because it's just good and bad. That's right. Yeah. It's the good and bad. Yeah. Okay, in you go again. This time I won't shock you with 50 volts. So this time we should see no shorts appearing. So as I work this control, this light might flicker, but it should not stay on. It does not stay on. So there's no accidental shorts in the tube anywhere. Well, I don't know what to make of that one test failing, but here we go on this. Push P3 and see it go in the good. P3 goes up in the good. So what we can do is we can throw another. I'm going to get another tube and stick it in here. I'm going to find out about this. Maybe my tube tester number 2 is not working. The short number 2 is not working. I got to dig out a tube. Okay, wow. I got 19 of those tubes in here. Eeny, meeny, miny, moe, pick one out. 35Z5. Made in Canada. Okay, let's give this one a try. We'll see how it comes out. We'll see if it fails on that first test, the ballast test. So 05370. 05370. What, did I win something? Did I win? What did I win? I did not win anything. Gotta mix these tubes up. The original one has the metal base. Okay, 35Z5, and I did the across here, and it's nothing else matters. Hey, there's a song like that, isn't there? A wonderful song, in fact. Yeah, 35Z5, 35. In you go. Most of the tubes in my tube collection I put through the tube tester like this and tested them. If they're really bad, they go. But if they're weak, I've been keeping them. So that's why before I use one, I have to retest it. And some of the more popular tubes, I have an extensive information about that particular tube in my collection because I have so many of them. I have a long spreadsheet. I'm going to show you this while we're looking at that tube there. I have a long spreadsheet. It's got 3,000 entries in it, 3,000 rows or something like that. And then information about tubes, including tubes I don't have. It's just a blank row. The other tubes I have information on where they're stored, how many I have, and sometimes I have the same tube listed 3 or 4 times because I've acquired it 3 or 4 times and I've stored it differently 3 or 4 times. So it's quite a messy spreadsheet, and I've been trying, can I clean this out? But 3,000 rows, I just go watch a YouTube video and forget this. That's kind of how it is. The other day I said, gee, I wonder if Mr. AI can help me with this messy spreadsheet. And the answer is yes. You can upload your spreadsheet. Now you got to pick the right AI to do this and the right software and all that. But it wasn't difficult for me at all. My spreadsheet is in Google Sheets, and that's the AI can absorb that. So I give it permission to go look at my spreadsheet for vacuum tubes, and then I started asking it English questions and giving it English assignments. Take my list, look down the list for tubes that you think are valuable that I have not assigned a value to, and tell me them. Here's a list. Now I can only do part of my spreadsheet. Yeah, and every tube's worth something, I guess. I don't know. But I got this out of AI. This would take me the rest of my life to try to generate stuff like this. This didn't work out well for a couple of reasons, but it worked. It didn't work out well because the AI kept saying, hey, I'm too busy right now. I got to do this later. And later never came. So in my 3,000 row spreadsheet, I just gave it like 100 rows to work out of. And this is what it found in those 100 rows. These are tubes that I did not assign a value to that I should have. Look at this one down here. That 5Z3. I got one of them. According to AI, it's worth $50. Now, how did AI figure this out? It knows everything. It's read a list somewhere that contains values for tubes, and it knows it. Yeah, $1,400. Should we believe that? My wife laughs every time I tell her what my tubes are worth. Just like me laughing now. She goes, oh yeah? Sell them. Okay, so another thing about AI, this stuff is coming at us so fast. There are so many advantages building up around us through AI that we don't even know about, and they're out there for us to use. Like this spreadsheet thing, I was shocked that I was able to do this. And it just opens up a whole world of things I might be able to do with it. And the thing is, you're talking to it in English. It's just the ordinary, everyday, conversational English. So, okay, pretty excited about that stuff. We're living in a great time. Forget all those other problems. That's just current events. Look at what's happening in the long run. In the long run, humanity is headed towards some fantastic future. That's what I think. And don't worry about the current events. Okay. Don't worry. No worries. Test this tube, Jen. So, okay, so we have it in for the balance test. Here we go. Short on 5, 4, 3, 2, 1. Yeah, I wonder if my... You know what this is proving? This is proving my tester's not working so good. But no, nothing on 2. So the fact that this tester didn't show a short on 2 doesn't mean much. We might as well finish this tube off. In this tube tester, you can make changes to these settings with the tube sitting there. As long as you don't... 0507, as long as you don't change this. 0507. Other tube testers, you don't dare change the settings while the tube is sitting in there. English should be set to 60. Yep, there we go. And rectifier. So we have 2 good rectifiers, the original and a potential replacement. We can always try it and see what happens if it makes a difference. And I doubt it very much. In fact, after doing that, we kind of have to try it. We kind of have to test it out. Oops. So the original, replacement, put it in. I wouldn't bet a penny on this making any difference. Volume up. Power's off. Okay, we hit the power and here. And it's exactly the same. So we're going to take this guy out. Careful, man, they get hot. Put this back in. See, like that hum comes even before any of these tubes got warm. So tubes can't really be involved unless there's a short inside the tube. And I think, with the isolation of the output transformer and that, shorts early in the radio, they can't possibly do this instantly when you turn it on. That's what I'm thinking. Why am I looking at this? I don't know. I'm beside myself. That's why. Okay, so we're going to do the output tube. Why? Because it's new. I think we're going to end up doing all the tubes in the end. 50L6. Very good. I radioed just a few weeks ago. It was supposed to have a 50L6 in it. It had a 35L6 in it. So this goes back to 50 now. And it must have been the 50L6 thing I was just talking about. So 50L6, JR, and then 53470. 53470. I don't have to double check it because if I made a mistake, you'd let me know. Yeah, but I am going to check it. 5347. 53470. 30. Oh, it's right there. 90. It should read between 4,000 at the lowest and 6,500 at the highest. So 4,000 at the lowest, 6,500 on the 6,000 scale. 50. So you could have something going on the primary side of the output transformer that's creating the hum that we can hear coming out of the speaker. That's quite possible. So when I said the tube's not necessarily not involved, I can't be sure of anything. Everything and anything I say on my videos, just really get out the salt shaker and find some grains of salt to go with it. Here we go. Looking for shorts inside the tube. If there was one, that might explain something. going to push the button and it should come up above my finger. Shaky, but it's up there. Very good. Okay, so there's nothing wrong with this tube. Nothing wrong with these tubes. But I'm in the tube testing mode here. I might as well keep going. And we'll just go on to the next one here. This is the Q. This is the Q. Yeah, it's got something written right inside the tube. Can you see it? 7A. 12 SQ7. Made by National Union Electron Tube. And you've never heard of that company? Made in the U.S. Okay, so it's a 12. Quickly, Jim, put this down to 12 before you blow it. 12 SQ7. So we're going to get it up here. 12 SQ7. 3 tests on this tube. 12.6 JX 1603. Shouldn't have said it that way. 1603 with a 2 at the end, 0 on the bias, 51 on the English. So this English setting is controlling the replacing good, but only when the meter knob is set to English. Then you get replace good. It's calibrated that way. But I often use the calibrated settings. So this is supposed to be between 600 and 1,000. So 600 is only here and 1,000 is only here. So it's going to come up into this area. And this is the triode section of the tube. So we're not really testing this to see if it's the cause of the hum. We're testing this to make sure it's okay. 12. If any one of these tubes had an open heater, the radio wouldn't have worked at all, because all these tubes have their heaters in series. So the fact that it worked to some degree means at least the tube heaters are intact. Okay, short test. Watching the shorty light. Flashing is good. Staying on is not. Okay. P4. Remember, yeah, 600. Boo! She's a weakie. She's weak. Now, in a case like this, what I like to do is double check some sensitivities, but the bias is set to 0 for this, so I can't. It's not gonna. It looks like this is a very weak tube. I'm watching the pointer to see if it's falling, but it's holding steady. Okay, that was the triode section of the tube. So this would be the amplifier that the sort of the preamp, if you like, for the output tube. Next test 05036. 05036. 0 and 0. P1. So now we're testing. There's 2 diodes in this tube. There's 2 diodes and a triode. There's 3 things in this tube. So we're doing 3 tests for the 3 things. And diode number 1. So yeah, I do is push P1 and watch the pointer come up above here where it says diode's okay. Wow. So what this is telling me is the cathode is worn out in this tube. That's the impression I get. So next test, it's hardly worth doing now. 0403 with a 6. 0403 with a 6. Okay, just moving one number. Right. 000 P1 again. So all 3 are testing weak. It's almost certain the cathode is worn out in this tube. Okay, gotta get ourselves a new one of these guys on there. I think I'll get one that's metal. Yeah, why don't we do that? 12 SQ7 metal. Yeah, I'm gonna stop for a moment here. Okay, it just took me a second to find my box. Can you see that? 12 SQ7s. See them all in there? I have an egg carton in there to separate them. Since these are such popular tubes, I've gone ahead and tested them all, and then I've registered them in a list. So I could look at my list and go, okay, tube number 23, tested this way or that. And I have some recent additions here. These are 12 SQ7, and these are glass ones though. And a 12 Q7. Yeah, that one there with the top. The S stands for single-ended on these tube things. So single-ended means all the pins are at the bottom. And so if you don't have an S, if it's just 12 Q7, then one pin is at the top. But you probably know all this. I never know who I'm talking to here. I could be talking to someone who's got 10 times the knowledge of me, or someone who's got 1/10. I don't know. So, well, let's pick one. Is there any that are not labeled? They would be recent additions, not tested. So this one, see, this one's not labeled. So let's start with this. Otherwise, if I use a labeled one, then my spreadsheet starts requiring attention. I make work for myself. Is this really a 12 SQ7? Yes, 12 SQ7. No doubt about it. So we're set for the diode test in the 12 SQ7. We'll start there and we'll just kind of do the tests in the other order. And I'm betting this is really what should be in the radio. So inside this metal can is a glass tube. There's a glass tube in there. When I was a kid, I thought these metal tubes, that was it. That they built them inside metal. But if you think about it for a while, you realize, well, it just can't be the case. Okay, she's probably warmed up. We'll do the short test. The main reason for doing the short test is to avoid doing the full test on a tube with shorts in it, because you can ruin your tube tester that way. Okay, this test is the diode test. So we're pushing the diode. Diode's okay. Wow, that's not a good result at all. Yikes. The tube's warming up. Ooh. I'm totally mistaken about what I'm doing here. 04036. 04. No, it's definitely P1. Well, that's not a good sign. I have to be honest with you here. Let's try this next one. Switch this to a 5 and repeat the test. A little bit surprising. 12 SQ7, but JX, yes, definitely. Well, it's warming up too, so it can't be the heater. 16, 1603 with a 2. 1603 with a 2. 0 and 51. So we're doing the triode section now. Well, I don't think this tube's going to make it. It's heating up, but it's not doing anything else at all. Okay, and we'll put this near the garbage can. Get another one. We got to get another one. Okay, we're gonna have to. I think from here I have to take one of these ones that I've registered. So let's take a high number, like 23. Be interesting to compare the result I get right now with the result from my earlier test. Okay, 12 SQ. Oop, just double check, Jim. Always 12 SQ7. We'll look and see what the readings are. While that's warming up, I'm just taking a look. This would be in my, I have a 12 SQ7, here they are. That's number 23. It ranked 100% in the Stark. 100%. What did I mean by that? Maybe I did. I don't know. It doesn't make sense. There's no percent here. Okay, but 100% sounds good. Sounds like it's a good tube. So, okay, did I do the shorts thing already? This is the triode test. And it's right up in the brand new spot. Okay, it's hardly worth doing the diode test at this point because clearly the cathode is good, but we will do it. 0503 with a 6. 0503 with a 6. B1. Oh, it's low also. Did I not get this? This is supposed to be 0. That won't make any difference. Well, it's coming up here. It's supposed to come all the way up to there. What did I say? I said it probably wasn't worth testing the diodes. 0403. Change this to 4. Push the 1. A slight bit better, but not much. This is not going quite as well as I would want. I want a good tube to do a good test. In here, let's try. That's interesting. I've got 2 tubes labeled 20. How did I manage that? Because I'm pretty relaxed in doing all this stuff. Sooner or later, we'll get a good one. Oops, all these tubes I'm dealing with right now, these are all pulls from radios, and they've all got wear on them. These are not brand new ones, so I do have some brand new ones. NOS ones hidden away somewhere. Okay, any shorts showing up? No. Flashing is good. We are doing the diode. We're doing the 4 diode. Still low. So maybe the diode tested is false. So when we change the 4 to a 5 and repeat, and then we'll switch to doing the triode. 1603 with a 2. 1603 with a 2. Well, I think probably the low reading here is something to do with the tube tester, and because we've got tubes testing high up here on the triode. We'll put this guy in the radio. Can this be in any way responsible for the hum? I don't. Well, you know what? No, I don't think so. Because, but it was a glass tube, and I'm putting in a metal tube, and there is a ground wire to pin 1. We will give it a go, but I think we're just gonna click it on and hear the same hum. Here we go. Same hum. Okay, next tube. Here. 12SK7, and somebody's repainted it here. Trying to make it look good. 12SK7, another very, very common tube. 12SK7. These guys travel together in radios because they draw the same heater current. And they're all in series. So if you're familiar with computers, who isn't? Chipset, you've heard of a chipset? That's a bunch of chips that kind of work together. Well, this is a tube set. 4765 with a 3. 4765 with a 3. My guess is the manufacturers came up with these tubes specifically to have a common heater current and to drop 120 volts. That's why you got a 35 and a 50 in there. 35 and the 50 in particular is for the output tube. The higher voltage give you more current, give more power. More power. Those tubes run hotter, they wear out sooner. 72. I better pay attention to what I'm doing here. 12 SK7. Press P for 1200. So 1200 is about here. That's where we would want it to come. 12 SK7. Now, could well be that fellow who fixed that radio didn't have access to a tube tester. And he may not have had the alignment equipment. Who knows? Most people can scare up a soldering iron and change capacitors, but beyond that, you need equipment and information and everything like that. Okay, here we go. Not that it's difficult to get the equipment these days. It's definitely not. Okay, so this guy, 12 SK7, should come to 1200 at least. 1900 would be nice. So it came up in here. That'd be really nice. No, that's not bad. So I didn't think that this tube is a bad actor. And it's a metal-clad tube. So the last one is the 12 SA7. It's a very, very important tube in the radio. National Union 12 SA7. Get this one out here. So that's two from this company. 12 SA7. 12 SA7. 12 SA7. There's two tests for this tube. JR 7346 7346 5 with a 5 21 on the bias and 34 on the English. So a low is just about 500 would be throw it out, or replace it rather, and 750 would be jump for joy. So just this little tiny band in here. Okay, this is the come back. This is the amplifier section of the tube. This is the mixer tube. Oh, did I do the short thing? I don't think I did. But what's happening to you, Jim? What's happening to you? You lost your mind. Oh no. I put the other tube over there. Yeah. Found my mind. Okay, back to what we're doing now. See how the roll chart can roll like this, and you look back at it and it's showing you different values here, and you can make a mistake. Real easy with these roll charts. You can also get quite confused about which tube it is you're testing. There we go. Okay, look for shorts. Well, that's an unusual thing to find. Now, some tubes, they will show a short. Look, it's showing a short on position 2. Oh, I think it's just sloppy switching. It's position 3. Now, I could find out what this is. I could identify the short, but I'm not going to bother. 12 SA7. Just double check our settings here. You want to abandon the tube because you made a mistake here without knowing it. 7346 with a 5. 7346. Right there's a mistake. 7346 with a 5. 734666 with a 5. Okay, let's go again. The short is gone. It's my fault. Okay. Up above my finger, maybe as high as this. Oh, it's just a hair below 500. Let's do a quick check on the line voltage here. It's just a touch low, and that's not enough to count for anything. So, another weak tube here. Let's do that again. Yeah, and this is a oscillator tube. Although we're not doing we're going to do the oscillator section now. Oscillator section works hard, needs all of its faculties. 5, 3, 4, 6. 5, 3, 4, 6. 5, 3, 4, 6 with a 7. 7. 21 and 34. 21, 34. Oscillator section, the same rating, interestingly enough. Must be above 500. So it's above 500. I'm watching it to see if it syncs. Sometimes you can see the pointer drifting downwards, and I think that's a bad sign. So this one, weak. The oscillator part seems okay. I don't think this can cause the hum, but it's a glass tube. So I'm going to find the 12 SA7 metal tube, and we will stick it in there. Okay, let's see how quick I can do this. 12 SA7. I can't do it quickly. Okay, let's stop for a bit. Okay, let's see what's in here. 12 SA7. I want a 12 SA7 metal tube. Here's one that's not labeled. Let's try this one first then. There's a couple more. So what's happened is, I have a certain number of tubes and I've done a certain number of things to them in terms of keeping records, and then I get some more. And so now it's a real problem to keep these things organized. So 12 SA7, and we're on the 12 SA7 here. Right now we're on the 3, 4, 6 with the 7. So we're on the oscillator section. 12 SA7. Normally I don't leave the video running while I do this, but not feeling normal today apparently. Okay, we'll check now. Shorts. Flashing good. This is the... Okay, so same thing. 500. That's up. Okay, now we'll do the other test. 7, 3, 4, 6 with a 5. 7, 3, 4, 6 with a 5. Okay, before, and this time same thing, about 500. So okay, so we got one we can put in there. This will be a metal one going in instead of a glass one. Is this going to solve the hum? No, I can't imagine. Later on we'll do some experiments. We'll put these glass ones back in. But for now, I've switched this entirely to metal tubes. And that's based on the pin number 1 connection underneath. Well, we should operate the radio just to be absolutely sure, because, you never know. Here we go. Okay, humming. This light is coming on really bright. That's a bad sign too. I'm going to turn it on again. I'm going to read the voltage. This is the amount of voltage that's getting past the light, so to speak. Come on, come on, come on, come on, come on, come on. It's not enough to operate this. That's not surprising. So I'm suspicious about the filter capacitors. I'm suspicious about the wiring in here. I'm suspicious about the obviously it's the hum that's really starting all the suspicions. I'm suspicious about how the speaker's connected to the chassis. I'm wondering where's the resistor that's supposed to go to the chassis. I don't know that that would help a hum like this any. I could isolate the speaker from the chassis, and I think the hum would disappear, but it shouldn't be there in the first place. Did he change a lot of resistors in here? In looking at this, I would guess this is a complete rebuild. This is a giveaway that he replaced this. All these resistors look the same and they all look new. If that's the case, even these capacitors look new. If that's the case, that he's gone ahead and changed all the resistors and all the capacitors, then the chance that there's an error in here is really, really high. And the reason for saying that is the radio doesn't work. And an error in here. Let's look at the power cord, how it's done. So power comes in here. We'll follow this one. Goes to a terminal and follows this green wire all the way to the switch. And then on the other side of the switch, the AC is going in two directions. Three. So there's so this is becoming B minus is what's happening. So that being the case, so it goes to here. From here it goes to the chassis, but it goes all over the place too. It goes here. And these two terminals are connected. Oh my gosh, you know, it's possible he's made multiple mistakes, and sorting this out is monstrous. If I had a diagram, if the serviceman had a diagram of the component layout, it would be a lot easier, for sure, to go through it. Oh my gosh. Oh my gosh. It kind of, you know, could be the result of shotgunning the whole radio. And the guy could have removed everything out of it and then replaced it all, and in the course of doing that, make 3 mistakes. And one of them's hidden. Oh boy. Okay. Aha. Oh boy. I can stare at that all day. I'm not going to get anywhere. Gotta stop here. Talking about weird and strange things. Let's go back to this wire. It comes to a tube pin where there's no pin. So this is, it's on the rectifier tube. That's probably why. So it's it's pin 4 of the rectifier tube. Pin 4. So there's not, the pin 4 doesn't appear here. So it's a spare. Why'd they bring a wire over to it? Sometimes you use the spare terminals as connection points, so you don't have to put in a terminal strip. You can just use these spare spots, like on this one over here. This is spare, and they've got stuff connected to it. But there's no reason to bring one wire over. And it sure looks like this has never ever been attached to anything else. And it looks original. I wonder if by some chance when they're wiring these things up, the wiring at the start of the initial few wires are put in and the chassis is good for 4 models. And then as it travels through and they do the different models, in some cases the wire they put in is not used. That's stupid. I can't imagine that's the case. So this tube, is the pin broken off this tube? No, no, there's no pin there. There never was. A lot of rectifier tubes have missing pins on the bottom. Why spend the money to put a pin there when you're making these tubes by the thousands and thousands of them? So the tiny savings adds up. That's a real mystery. What's going on there? I don't know. I just have no idea why would this be there. Okay, that didn't solve anything. Nothing is solved here. This is just it's a mystery wrapped in an enigma, all that kind of stuff. I'm just standing here thinking about the speaker connection to the chassis, this thing. In some cases, the speaker frame is tied directly to the voice coil, like one side of the voice coil. It's grounded, and it would often show up as a ground symbol on the schematic. It's screaming out at me that this is crazy to do this with the speaker. How would it get like that? And you know, the wire is no way that wire made it all the way. Like if I took this wire and kind of bent it down, you know what, it might have. But why would somebody change any of that and do this with it? Nobody would go from having, you know, isolated speaker secondary to, you know, doing this to it. Especially when the schematic doesn't show it this way at all either. But that would certainly explain why a hum would appear immediately upon turning on the radio, because the power is attached to the chassis through this capacitor. That's a stupid thing. I was going to say, well, the switch is off, then it's not connected, so we shouldn't hear anything. Am I going to try that? I'm trying it. We don't hear anything. No. Well, I don't know. I'm going to sit here silently staring at it. I better stop. In fact, this might be the end of the video. Let me check how much time I've put in here. It's a lot.